of ML, machine learning, and then we have learned pre-processing, visualization, and then also we have learned some libraries, NumPy and Pandas. So today we are going to continue, and then let's get ready. I'm sure you are with your machines already. I mean your PC installed with the necessary IDEs to use for this training. Okay, so it is my pleasure to invite our facilitator for today. Our facilitator for today took us in the beginners stage, and she did a very good job. And so she's going to be taking us today on regression. That's the supervised learning. And don't forget that we learned types of machine learning. We have the supervised, unsupervised, and then we have the classification and the regression. So she's going to be taking us through the regression algorithm, and it's going to be very handsome. So with your favorite emoji, I wanted to celebrate Adejumobi Joshua as she takes the mic and starts the training immediately. So thank you very much. Please, with your favorite emoji, I want to see your favorite emoji, the fire emoji, the strength emoji, and the chat to celebrate the facilitator for today's training, Adejumobi Joshua. Okay, so over to you, Adejumobi.
Okay, thank you very much, Tejumola. So I want to share my screen now. Okay, please confirm if you can see my screen.
Yes, we can see your screen.
Okay, great. So I know that just like Tejumola said, we've been taught a lot this week. We've been introduced to what machine learning is, what deep learning is, even though we're just introduced to what it is. We've also seen how to make use of libraries like Pandas, NumPy, and how to perform data preprocessing with it. We've seen how to create some visualizations in our previous classes that we were taught this week. So I'm sure we all understand those concepts. So today we'll be concentrating on a part of machine learning, which is known as supervised machine learning. So before I move on to what we have today, so does anybody want to tell us what they understand by supervised machine learning? So you can drop your answers in the chat box. What do you understand by supervised machine learning? When we say supervised machine learning, what does it mean? Wow, so nobody wants to respond. Okay, so I can see response from Boma Akins. She said, supervised machine learning is when the data set to be worked on is labeled, okay, which shows that you have an understanding of what supervised machine learning is. So when you are talking about supervised machine learning, you have yes, so I also love the answer from Rashid. Training a model with a predefined answer, labeled data set is used. So great response, which shows that we all have been following with what we have been taught. So when we say supervised machine learning, your data set has a target. It is labeled. It has a label such that you give your machine some specific features and also the target. You allow it to learn with the features and then the target. Then you now test your a model and say, okay, given these new features, I've taught you this thing before, right? That when you see this, this is the answer. When you see this, this is the answer. Okay, now, so given this, what will be the answer? So that is what, in simple terms, supervised machine learning means. So supervised machine learning, we now have, under supervised machine learning, we have regression, and then we have classification. So when we say regression, the target, that is our outcome, contains some continuous values. So our target has some continuous values. That is when you have regression. So you classify your tasks based, your supervised machine learning tasks, to be either regression or classification based on the outcome. So if what you want to predict, if it is a continuous value, then you know that, oh, this machine learning task is what? Regression. But if you have some discrete values that you want to predict, then you know that, oh, this machine learning task is what? Is classification. So I'm sure we all understand that. So for example, now, let's say you want to predict the prices of houses. You want to predict the prices of houses. You know, you are going to be having numeric continuous values. So in that kind of scenario, you know that, oh, the task is what? Is a regression supervised machine learning task. And let's say you also want to predict the salaries of some workers. Oh, what would be the salary of this particular worker based on the years of experience, the skill set, and all. So you know that that kind of task also is a regression task. So given this example, can anybody give us more examples of what they think regression tasks will be? Okay, electricity consumption. Okay, based on some features. Okay, what will be the electricity consumption of this specific house? Yes, predicting stock price. I can see from Chris. Okay, so great to see that we all understand the concept of regression. So I see how people are saying the price of rice. All right, so great responses, we all. Great to see that we understand the concept of what? Of regression. So moving on, we have different models that can help us to solve our problem anytime we have a task on regression. So now that we know how to determine if a specific machine learning task, we know how to determine if it is regression. So which models will be the appropriate one to use whenever we know that, okay, this task that I'm saying is a regression task? Okay, which model will be the best to use to solve this task? So the first one we'll be seeing is linear regression. So the first one we'll be seeing is linear regression. When we say linear regression is saying that there's a linear relationship between your features and then your targets, that is your answer in layman terms. So I'm sure we all are used to this normal equation of a line, which is y equals to mx plus b, which we've learned in our junior school mathematics. So we are just implementing what you have been taught in junior school. We are just implementing it here. So your y is your dependent variable, what you want to get, your answer, your target. So that is your y. I'm sure we can all see my screen, and we can see where my cursor is pointing to. So this y here, it is your dependent variable, your target, and in simple terms, your answer, what you want to get. And the x, they are your what? Your independent variable. So your x, they are your independent variable. That okay, given. So let me use a popular example that we all are very used to. Let's say you want to convert temperature from Fahrenheit to Celsius. So when you have a temperature value in Fahrenheit, you know, you have to do some calculations and then you get your value in Celsius. So it is depending on the value that you have in Fahrenheit. That is what the Celsius value depends on. So your X is your independent variable. So based on this factor, and this factor, what will the value of Y be? So one of the examples that we gave is, let's say we want to predict an employee's salary. So that salary that you want to predict is the what? Is the dependent variable, which is your Y, which is also the target, which in simple terms, the answer that you want to get. So the independent variable will be things like the employee's what? Years of experience, the employee's skill sets. Can anybody give me more features that they think will be useful when you want to predict the salary of a person, of an employee rather? So you want to see the years of experience, you want to see the skill sets. I've given us two. Somebody said the person's IQ. Okay, great one, Riri. I can see the educational level. Yes, the years of experience and years of training. So great one. So these are the independent variables. So when I put all this together, all these independent variables, what will the value of Y be? So that is your target and what you want to get. So we also have the slope, which is M. So, okay, if I add if I change a specific independent variable this way, okay, how would it affect my dependent variable? So in simple terms, we understand how to identify if a machine learning task is regression. That is one. Age, yes, working hours, great responses. I can see that we are following in his Odushola is saying his current salary band. But we might not want to put any information about the employee salary so that we'll not be giving our model hints about the answer that we want to get. Okay, so I was trying to do a brief repetition of what we've learned in this class. We've seen how to... Yes, great responses, you all. We've seen how to identify if a machine learning task is regression. And we've also seen a model that we can use once our task is regression. And that model is a linear regression. And everybody in this class, we all know that when we have a linear regression, that means it is used to model a kind of linear relationship between your features and your target. So I'm sure somebody will have a question. You might have a question in your mind such that, oh, what if the relationship between our features and our target, that is our answer in simple terms, what if it is not linear? Don't worry, we'll get there and we'll see how to solve that kind of problem when we get there. So moving on. So I'm sure we are all bosses now with using NumPy, Pandas, Matplotlib, as we have all been taught this in the previous classes. So the first thing I want us to do, I'm sure we all have our laptops open at our end, and then you've launched Jupyter Notebook on your laptop. So the first thing I want us to do is to import the libraries that we'll be using for today's tasks: NumPy, Matplotlib, and then Pandas. So import NumPy, import Matplotlib, and also import Pandas. Okay, so if you've successfully imported those libraries, let me know so we can move on. All right, great one. So I'll run mine here. So yes, I expect that everybody would have been able to import this, as we've been working with this since Monday. Import NumPy as MP, Matplotlib, and then also Pandas. Okay, so now we want to create a list with 6 rows. Actually, indexing with Python starts from 0. I'm sure we all know that in this class. So for the first row, we are giving it values of -1, -1. The second row, I'm sure we can all see my screen. 1 and 2, the third one, 2 and 3, the fourth one, 4 and 3, the fifth one, 6 and 5. And then the sixth one, we are giving it 7 and 8. So once you are done creating that list in your variable, which you can name data, so you want to see what is in our data variable, and then you get this, like you can see on my screen, you get it as your output. So I'm sure we all must be done with creating that list now. All right, and I'm sure that we've been taught that we do not want to work with lists, right? When we want to impute this to our model, we want to work with arrays. So now we need to convert this list to an array. This list that we created, this data list that we created, want to convert it to an array. So we are going to do this with 2 ways. So the first option, can just go with the first option, right, is to create a data frame. I know that to create a data frame in Pandas, you have to use pd.dataframe. So that our list value, you pass it into it, and then we know that we created 2 columns, right? So you are going to name the first column X, and then you also name the second column Y. Okay, so let me do this so that you can know that, okay, this is what we are working on at the moment. Yes. So if we want to check how our data set looks like, we can see what we have. We have 2 columns, X and Y, and then we also have 6 rows. So we have a list, we created a list, right? And then we created a data frame from this list. So of course, whenever we want to pass our values into our machine learning model, we do not just want to pass X and Y together. We have to differentiate between X, and we also have to differentiate X and Y rather. So we want to split our data set. So we want to split our data set into, okay, so that it will contain only values of X, and then the second one will contain only values from what? From Y. So iloc, what it helps to do is that you can select part of your data using only numbers. And I'm sure you know that loc, we use the names of the columns itself, while iloc, we use the column index number. Okay, so now for our X, which is the features, can anybody tell me what X is? What kind of variable did I say X is? Just to be sure we are following. Is X the independence variable or is it the dependence variable? Okay, great one. I can see that we are all following. So for our independent variable X, which is the features I want to pass to our model, right? So we are telling iloc that we want to select all the rows. Of course, this example data set that we created is not very large, right? So we are selecting all the rows. That's why you can see that this column here, we are not putting any number in it. So after the comma is now talking to the columns. So before the comma, you are saying what you want to select in the rows, but after the comma, you are saying what you want to select in the columns. And using iloc, you know, you have to do this, select it with what? The column index number. If it is loc, you know, you have to select it with the what? The column names. So now this part before the comma, it is selecting what? All the rows. While for this second part, after the comma, it is selecting what? The column before the last one. So we are just selecting the column before the last one. And then for our Y, you can see that we are selecting column 1. And we know that Y is in column 1. So another way to do this, if we don't want to slice this like that, so let me see the masters in the class. If I don't want to do it this way, that is, I just want to pick X. So to make the question more explanatory, if I just want to pick the first column, which is X, so what will I put here instead? This highlighted place. I just want to pick only X. What index number would I put here? All right, great one, Boma Akin. So I'll just put 0 if I want to pick only X. So great to see that we are all understanding. So now we've split our data set into what? X and Y, which is our dependent and our independent variable that we want to use for modeling. Okay, so here to see the shape of our data set. When I say shape, want to see the number of rows and columns that we have. Let's say want to see the number of rows and columns in X. We just do X.shape. So you can see that. And also, if we want to see the number of rows and columns in Y, we just do Y.shape. So this X.shape is telling us that we have what? 6 rows in X and 1 column. Great responses. So this is telling us that we have 6 rows in X and just 1 column. While for Y, we just have only 6 rows. And of course, we know we can use type to check what type of data does X contain and Y contain. So I'm sure we are all bosses of that. Aside matplotlib, pandas, which other was imported? Okay, numpy was also imported. Imported pandas as PD, numpy as NP, and matplotlib as .pyplot as PLT. So we imported 3 libraries. Toluwani. Oh yeah, I logged into work. Okay, so let me go back to that. So this is it. So we've been able to do 1. We created a list with 6 rows and 2 columns. And then we said, okay, we want to use this data in our machine learning model, right? So we do not just want to make use of a list that way. So we converted it. Want to represent it in form of an array. So we converted this to a data frame. And then we passed our list. And then we told this data frame that this data frame function that, okay, our list contains 2 columns, which we want to name what? X and Y. So that is why you are seeing columns X and Y here. So after creating the data frame, the next thing we did was to split our data into X and Y. So X will contain values from only X and Y will contain values from the column only Y. So we know how to do this. And then we used shape to see the shape of our data. Oh, how many rows and how many columns do we have in our data set? So let's say we want to see the type of X. So we know that X is now is an array. Why? Because we only selected that part from our data frame. And then also Y is also an array. All right, great one, Toluwani. So we know that Y is also an array, X is now an array. So then we can now use them as into our model rather. So I'm sure we all have been able to follow to this part of creating a list with 6 rows. And then we converted it to a data frame at first, named it with X and Y because we created a list with 2 columns, and then we extracted the values from column X, and we also extracted the values from column Y. So after extracting the values, we can see that yes, we now have an array. So if you have gotten to this point with me before we move on, let me know in the chat. If you are experiencing errors, let me also know in the chat before we move on to something else. All right, so I can see Ali Lawal. I've been able to do that. Abib Rere, if I'm correct. All right. Great to see that most of us have gotten to that point. We've been able to create a list. Okay, so we've been able to create a list and then converted us to a data frame before extracting values of our columns out. Okay, X, they are the features, while Y is the target, what you want to predict. All right, so the model we are still focusing on is linear regression. And at the beginning of this class, I told us that whenever we say linear regression, there is a dash relationship between the features and the target. So can you tell me the kind of relationship between the features and the target when we say linear regression? Great one, wow. So there's it will model is as a linear relationship between the model, between the features and the target. So now I want to use sklearn library, we want to use scikit-learn library to implement linear regression. You know that at the beginning of this class also, I said that linear regression uses this equation from our junior secondary school that we all are so used to. Favor, continuous is for regression. When you want to predict continuous values, right, you know that you are working with regression. But for linear regression is going to say that, okay, between the features and the target, there's a linear relationship between them. So linear regression might not be the best to solve all the kind of tasks, because we might not always have a linear relationship between our features and our targets. And I said that at the beginning of this class, and we'll also see how to deal with that as we move on with the class. Okay, so once we see how to use scikit-learn library to implement linear regression. So the first thing is that we are going to import this our linear regression model that we are so interested in seeing how it works. We are going to import it from scikit-learn using from sklearn.linear model, import linear regression. So now that makes it 4 things that we've imported in this class. We've imported NumPy, Pandas, Matplotlib, and then now we are importing what? Linear regression. So I'm importing linear regression from sklearn.linear model, import what? That model of interest. So to initialize the model, you use this that you can see that I am highlighting. You can say your model equals to linear regression, then open brackets and close it. So you might not name yours regressor. You might name it can name it model 1, linear regression 1. Oh, my first regression model. Anything you like, you can name it anything you like. It's just a variable name. This regressor here is just a variable name. And then the linear regression model, we are initializing it here. Okay, so JJ is saying it's a class, you create an instance of it here. So we are just initializing it into our work here. We are like calling it here. So we want to make use of our linear regression model. So that's right. So I'm sure we all have been able to do this, create a variable name, and then call our linear regression model into this notebook that we are working with. All right. So in layman terms, we've been able to bring this linear regression model that we want to work with. So now, just like we have been taught, we have supervised machine learning. So we now want to see how it learns now. So supervised machine learning, we all know that, okay, you have some features. You are giving your model that, okay, we have these features and we have this targets. So we have these features and then we have this target. So given this feature, this is the target. So you're telling your model, which is in our case, the linear regression model, that we've called, that we want to use in this notebook of ours. So these are the features, and our what independent variable, which is our feature, is contained in what x. These are the independent variable x, which can also be called the features. And this is our what target y, which in layman term you can call it what the answer that you want to get. Okay, so you are giving this that, okay, these are the features and this is your what? This is your target. Given these features, these are the targets that you get, or these are the answers that you get in simple terms. Given this feature, oh, these are the answer that you get. Given these features, oh, these are the answers that you will get. So how would you code that out? So to code that out, you just have to do fit. So fit x and y. So your x is your what? Independent variable, while your y is your dependent variable. Yes. So you are telling us that, okay, given this, you got an error. Okay, so which error did you get? So given this independent variables x, these are the answers y. So our data set is not really large, right? So that is why you can see that we got a result immediately. So as you move on, if you look at the linear regression documentation, okay, so that means you've missed a step from what we did before. So before coming to you, let me complete this. So when we move forward, look at the linear regression documentation, yes. So when you look at the linear regression documentation, and I think just as JJ said the other time, you would see. So let me see if I can new share so I can show us the documentation. Yes. So for this documentation, you can see the parameters rather that you can add to this model. So as you move on, you can add these parameters to your model. Okay, so I see that some of us are already getting results. Some of us are already getting output. So we'll do this one after the other. Let's see. All right, so I can see that some of us have already moved on to the next thing we want to do. So let's start from the people having errors. Yes, so Eurocruise. So starting from Eurocruise, so the first thing we did in this class was to create a list, right, with 6 rows. And then we created a data frame, and then we extracted out X and Y that we needed. But in your case, maybe you missed a step or something, but you can still reshape using dot reshape so as to convert it. Oh, okay. So Ali Lawal is helping you with that. Omotayo, which error did you get? You can drop it in the chat. Yes, Ibekwe favor. We'll be moving on to what you did. I think you used dot score, which is to show the coefficient of determination. We'll be moving on to that soon, if you can hold on. Okay, so I can see that we are left with Eurocruise. So Eurocruise, you missed a step in what we did. So you can use dot reshape, right, to convert it to a 2D array, just like, you know, I think I told us this at the introductory level class that whenever you have errors, right, somebody somewhere has encountered the error before. So always try to read and understand what your error message is saying. Error messages will also help you to see that, okay, this is exactly where I'm making a mistake, and this is exactly where I got it wrong. So I also told us about the different types of errors that we can have. We can have syntax error, we can have name error, we can have a lot of things. So you should change that to a 2D array instead of 1D array. So I think I've responded to all. Just remains our favor. So Omotayo, which, okay. Yes, Eurocruise, you're supposed to extract X and also extract Y. The way we first converted the data, like we have a data frame. So we want to just extract each of those X colon and you want to also extract Y colon so that you can have arrays. Yes, you can also reshape it, just like I said before. Okay, so I'll do that. No. X is a variable. So X is a variable. So you can name it anything at its end. That's Ali Lawal. You can name it anything he likes at its end. It is a variable. In fact, the way I did X and Y, another person can decide to do array 1 and array 2. So they can name it anything they like at their end. From the top, what do you mean from the top? Rashid Ayedun. So from which part did you get lost? Because I'm sure that before moving on, I asked us if we all have been able to check if we the type of our data set, if it is an ND array. Okay, you're not lost. All right. So from which part? Because we've done a lot in today's class. And we still have a lot to do. So that is why I asked. You know, before moving on, I asked that, okay, this is the type that you have at your end. Is it an ND array? And everybody said yes. So now, after importing our libraries, we created a list, converted it to a data frame. And then from your data frame, I'm sure you all have a data frame already. And I'm sure we are masters of this already. Even somebody answered that, okay, if you want to extract only column 0, we know how to do that. All you just have to do is your data set dot your ilog, pick all the rows, and then pick the 0 colon. Then for Y also, pick the first colon, and then all your rows. And then you get that. You have to tell me which error you are having. Cruz, do you have a data frame already? Yes or no? Rashid, which particular error are you having? Okay, so I can see that you have a data frame already. So extract variable X, extract only colon X. Extract it. So somebody is having name error, and I'm sure that in the introductory class, I told us that anytime you're having name error, then we know that Python is case sensitive. So anytime you're having name error, then you should check how you named your variables. So you are the one actually making mistake. Python will not make mistake. The mistake is actually coming from you. So check how you named your variables. Oh, did you name it initially capital letter X? And then when you now want to use it, you are now using small letter X. Of course, you have error. So check how you named the initial one. So check that, Kingsley, you want to check that. So Cruz, just do what I said. You have your data frame already. Just check. Good. Make sure that you've extracted X, which is in column 0, because you are using ilog. If you do not want to use ilog, you can use log, and then you extract it with the column name itself. But then let's just continue using ilog. Then for Y, it is in column 1. Extract all the rows, just like you can see on my screen, and then pick it in column 1. Then check the type. We are all used to checking type. We know how to check the type of a number 5, if it is integer, if it is float, if it is a string. The same thing here. Check the type. What kind of values does S contain? Is it an ND array? What types of value does Y contain? Is it also an ND array? So that's anytime I'm asking us, if you've not been able to do it, please let me know. Don't just say yes. So can you copy and paste the code that you use to extract X? Let me see that, Cruz. So for the person having a name error, have you checked what you named that variable initially? Have you checked it? Are you sure it is the same name that you gave it to it above that you are now using in the linear regression model? If not, that's for Kingsley David. So if not, you want to check that. Oh, okay. So I can see that, Kingsley David, you're having your error because, oh, you didn't put quotes on top of the X and the Y. So you know that from the introductory class, we also said that if you just tell Python X and it is not a variable, it will not know what X is. So you have to put quotes on top of it to know that, okay, this is a string, right? It is saying X is not defined because you've not created any variable X before. So you've not created any variable X before in this Jupyter notebook that you are working on. So that is why it's telling that, okay, there's no variable X in here, but then you have to put quotes to tell it that, okay, it is a string. Put quotes on X, put quotes on Y. Don't put quotes on them together. X differently and Y also differently. So that's for Kingsley David to solve your error. All right, so Rashid, you've not sent the error you're having. Kingsley David, I think that should solve your error. Okay, so I can see Cruise. So you are selecting everything. And then, of course, you have a series. That is because it's either you select one as select 0, right? As to tell us that, okay, you are selecting only colon X. Or just in cases where you might have more than one colon as features. That's why we are using this slicing. We are not just picking -1. So we are slicing. We are saying that we are picking all rows before the last one. So -1 is not picking the colon X actually from your data set. So that is why you are making an error. So if you put a colon before that, before your -1, you're saying you're selecting all values before -1. Or instead of putting -1, just put 0 to select colon X. So I think that should solve your error, Deboye. Sorry, Cruise. So for Deboye, X is just a variable name. You can name it anything he likes. Just to make sure, but you must make sure that he uses it all true. Okay, Rashid is saying is okay. So do it again, like run it again from the beginning, right? So try and run it again from the beginning. Cruise, or just select 0, like as the colon number for X, yes. Or you can also use lock and select X as the colon name. So anyone works. Okay, so Azan, wow, is how we've moved past this place. And nobody asked a question, and I asked, but then we are still bringing us back here. So I'll just paste this for you. I can't see your notebook now, Cruise, but I'm sure that you are missing something. I'm sure you are missing something. So I know Kingsley have been able to solve his own. Who again? Rashid. So why is -1? Okay, so at the introductory class, we were taught about negative indexing, right? So we know that, if we have some set of values when we want to slice, we know that we can also start with, we can also use negative indexing. -1 is talking about the last part of a list. And then we know from the introductory class also that when we are slicing this way, it will pick whatever value before what you put here, what you put after this semicolon here. So here, what we are just saying is that pick all the values. So you won't really see the impact here because we just have 2 colons, right? So pick all the colons here before the last colon. And I asked when we were doing this that what other ways can we just pick X also? And somebody said we can just put the column number, which is what? 0. Wow. So once you are doing iLog, it just helps to index. You index with numerical values. You when you do iLog, you index with numerical values. I also mentioned that when you do log, you have to use the definitely. So you were doing something, probably doing something wrong before. So when you use log, you are not using the column numbers, right? You are using the name of the column itself. So that's one of the major difference between iLog and log. So they just help with what? Indexing rather. So iLock, lock, they help with indexing. Rashid, we have a lot to do today, but for lock, iLock. Sorry, for lock, you just take away the I. Just take away the I for lock, and then you put your the colon name where you should have the instead of number, you put your colon name there. So I'm sure you can try that out at your end, but we have to move on as our time is fast spent. So now I'm sure we all have gotten here. We've been able to fit X and Y. So great one, Justice. So we've been able to fit X and then Y. So I'm sure nobody has any more errors, and they've been able to move to this specific point. So now, what .score does, I think, I can't remember the person that asked the question. I think that was Favor, that you got a value of 0.8 something. So I'm sure you did the name of your, what you named your model, .score. So .score in regression, what it does is that it uses a metric which is coefficient of determination. Found input variables. So if it is telling you that, oh, Cruz, you have a value error, you have to go and look at how you created your list from the beginning. Go and look at how you created it. That is where the error is coming from. So check how you created your list and then confirm. Maybe you just put in one. Of course, you are not supposed to do x.y when you do regression.score, David. It is x, then a comma, and y. So it's because of that dot. That is why it is telling that, oh, x has no attribute of y. Because when you do something dot, you know, pandas, sorry, the name of a data frame dot shape. Shape is an attribute, right? When you have a data frame. But now you're doing x.y. That is why it's telling you that, oh, x has no attribute of y. So it should be x, comma, y. And what coefficient? Okay, we have another error. Yes, so back to .score. So in regression, what .score shows is the coefficient of determination. So that's also known as R2 score. And what R2 score does is that it helps to measure the variance in the data set, and the higher the value of your R2 score to 1, the better your model. So it just shows the difference, right, between the real value of y and the, yes, it's possible for you not to have the same exact value. So it is very possible because we might not use the same exact numbers. So it's very possible. So coefficient of determination, what .score does here? It is what? Coefficient of determination. And then it helps to measure the variance in the data set. So the closer it is to 1, the better the model. So you can see that here we have a value of what is 0.89, which is telling you that, oh, wow, this model is trying, right? But then it can be better. And just like I said, y equals to mx plus c the other time. So you can see that we can also get our intercept here using the name of your model, which might not be regressor at your own end. Whatever name you named your model at the beginning of this class, dot intercept underscore, then you get your value of intercept. You can also get the value of your coefficient using dot coefficient. Okay, so moving on, we want to see how the correlation between X and Y. And to see the correlation between X and Y, you can use dot core function, that is CORR. CORR, which is dot core, to check the correlation between, you just have to do dot intercept Eurocruise. The name of your regression model, dot intercept, then put an underscore, then you get the value. So dot intercept, put an underscore. So the name of your model, dot intercept, then you put an underscore. So I'm sure you should get that now, you should get the value. So for dot core, you just use to get the correlation between your X and your Y value. So what we are doing here, we are showing you that, oh, of course, values for X will correlate with X. So that's why you can see that we have 1. Values for X and Y, you can see that we still have an high correlation to it. So the way correlation works is that when the closer it is to +1, so that means you have a positive correlation. There's a positive correlation between X and Y. While the closer it is to -1, it means there's a negative correlation between what X and Y. So now we are having okay, so now we can see that we have an high correlation between what X and Y. So Eurocruise, you can let me know if you get that now, if you've been able to work get a value for the intercept. If not, you can also let me know in the chat. Okay, of course, we've seen how to train our model using .fit. We've seen how to train our model using .fit. So now, how do we now know if our model has learned what we taught it? So how do we know if our model has learned what we taught it? So that is why we want to predict and test what our model understands. So to test the model, you use what? .predict. So now, you know, when I was explaining, I said, when we were training the model, we gave it what? Some set of features and then a target. We gave it some set of features and then a target. We said, okay, these are the features and these are what? The target. These are the features, these are the targets. When you see this combination of features, this is the kind of targets what you will get. When you see this combination of features, this is the type of target that you would get. So now we want to know that, okay, I've trained you with features and targets. So now I want to now give the model only the features. So I want the model to think, right, and give me back the targets. So the model giving the features. So when the model was learning, giving the features and the targets, the model must have brought out an equation linearly, which is why we're taught y equals to mx plus c, which is why you can also see that we had a value for intercepts and we also had a value for our coefficient. So now the model, using these intercepts and our coefficient values, it will now use it with our independent variables to calculate a new value for our targets. So that's the simple logic behind linear regression. So it has gotten an intercept and it has gotten a coefficient just for linear regression, please. So it will use this, bring out its own equation, then use it to calculate our target. So now we want to predict that, okay, given these features X now give me some prediction value, which is why you can see that we are using the name of our model .predict, and then we are only passing in our features. So the name of our model anything you named it at your end. So the name of our model, anything you named it at your end, dot predict then the features, that is your independent variable, anything you named it at your end. You might not name it X, you might name it anything you like. So whatever you named it, you put it here. So now that we now have some prediction values, I'm sure we all have been able to do the name of our model, then just predict the independent variables to have some of our predicted values. Then you save it into a variable name. So we now want to see how our predicted values, right, how it fares to our features. So this might take some time to write, so I'll just copy it for us. You know, and at the beginning of this class, we imported matplotlib. So now that is the function that we want to use now to plot our dependent variable and our independent variables, the predicted dependent variable and our independent variable. So we want to see if truly we have a linear relationship between them, because you know I told us that whenever we are doing linear regression, there should be a linear relationship. It models it as a linear relationship between the features and the target. So now we now want to see that indeed is there a linear relationship between this between our features and the predicted values that we have. So that is what we want to check now. So if you've been able to get your predicted values, please let me know in the chat. You've been able to use the name of your model dot predict the your independent variables, whatever variable name you give to it. So you should have some predictions already. So it is these new predictions that we have that we now want to check. Wow, so Hero Cruz is on top of his game now. I can see that he has been able to do that. So now, using that, all right, great one, Alawa. So using that, we now want to see, okay, so what is the relationship between the our features and our, so using the code I sent, scroll up to the chart and you see it. What is the relationship between our features, X, independent variables, and our dependent variable, Y? So once you run this, so you can see that, oh, we have two lines here. You can see that this straight line does not really fit. It does not really fit into, this straight line does not really fit into what we want to do, right? So it does not really give a linear relationship because not all the points, right, are being met. So we cannot say that the relationship between our X features and Y, we can't say that is linear, exactly, not the line of best fit, yes. So linear regression is not the best to model this kind of data, because after visualization, we can see that, oh, we do not have a linear relationship between the features and the target. So when you see this, you can see that, oh, linear regression is not the best model, right, to use for this kind of scenario, because it does not fit to all the points in our visual. So in this kind of scenario now, what then do you do? So before moving on, let's first add our predicted value, right, which is y hat. Okay, so when we say that there's a linear relationship between, let me go back to the beginning of the class so that you understand. So when we say there's a linear relationship, I'm sure we all might have done this in economics, might have done this in math, might have done this in secondary school. So that's what I'm saying. We are just applying things that we've learned in secondary school. We are just applying it here. So now we know that for demand, anytime we say, oh, there's demand, we know that for demand, the higher the price, the lower the quantity demanded. The lower the price, the higher the quantity demanded. So for demand, there's a linear relationship between price and quantity demanded. The higher the price, the lower the quantity demanded. The lower the price, the higher the quantity demanded. So for that, there's a negative relationship, right, between, there's a negative linear relationship between price and quantity, because once the price reduces, more quantity are bought. Once the price increases, lower quantity of things will be purchased. While for supply, the higher the price, the higher the quantity demanded. The lower the price, the lower the quantity demanded. So there's a what? Positive relationship. There's a positive relationship between between price and the quantity, because you know that as the price increases, the supply was also increases. As the price reduces, the quantity supply rather also what reduces. So I'm sure you understand that now. Favor. So that is what we mean when you say linear relationship can have. Okay, so we can move on. And when it is not a linear relationship, you can see that, oh, it is not even, there's no relationship at all. The points are just scattered all over. Yes, because we still have to move to classification today. All right, so we can see that, oh, that is not the line of best fit. So it is not, we do not have a linear relationship between those features and then the target. So now what we can do is I'm sure you know how to add a new column to a data frame that you've created before. So in our previous data frame, which we named data set, I don't know what you named it at your end, you can add a new column, say y print, then it will be equal to the variable that you use to save your predictions. So y hat, so you add a new column to your data frame from the variable that you saved into your predictions. So now we are just trying to visualize here. We are just trying to visualize here. Because of our time, I'll be faster. Yes, Toluwani, just use exactly what I sent to you above. so you would not make mistake when writing something. So now we've trained our linear regression model, we've tested it, we've also visualized to see the kind of relationship between the features and the targets. So after doing this, the next thing we want to see is to evaluate. Of course, you've trained, you've tested, you want to see, okay, given what my model predicted and the original values, is this model even doing well? Yes, I'm coming to that, Paul. So given that these are the values that my model predicted, this is the original values, right? Is my model doing well, right? You want to evaluate your model. Linear regression model, I have trained you. Now I gave you a test, giving only the features. Now the model was able to give me some targets as my answers. So given the model's answers and the one that I have initially, I now want to see, oh, how well is this model doing? So the two things we need for this are our what? Original answer, which is our original target, and then what the model predicted, which is our what? Predicted target. So we need the original target and we also need the predicted target to evaluate the responses from our models. So we have different, we call metrics, evaluation metrics for regression. So we know in this class, we've been taught how to identify if a task is a regression task. We know that, okay, we've learned about a model that we can use, which is what? Linear regression, to deal with regression tasks. And now I want to see how to evaluate. What evaluation metrics do we use for what? Regression tasks. So we have some of them. We've seen one. We've seen coefficient of determination, which is R2 score, in which we also know that the higher the value of our R2 score, the better. So we have others like the mean absolute error, the mean squared error, and then the root mean squared error. So when we say error just subtracts the original from the predicted. Oh, the original target minus the predicted targets. So once you've done all those subtraction row by row, the cost function will just help you what? Sum up everything you have. So going to the mean absolute error. Mean absolute error is the mean of the absolute of these errors that we are talking about. So the original target minus the predicted. So you get the absolute values of each, sum it up, divided by the what? The number of data points that you have there. So the mean squared error, you still do this, but then you have to square each of the subtraction from the original target to the predicted. So I can know that you can see the formula on your screen. And then for root mean squared error, still the same thing, but the only difference is that you have to put a square root on top of your mean squared error. So I think that you should be able to remember that easily. So for regression evaluation metrics, when the value you are predicting is a continuous value, you want to make use of evaluation metrics such as root mean squared error, mean squared error, R2 score, coefficient of determination, mean absolute error, MAE. So I'm sure your question has been answered, Paul. So now I said that the only two values that we need, right, to perform evaluation is what? Our original Y and then the predicted Y. So that is what we are going to extract out from our data set. So as bosses that we are, I know we'll be able to extract Y, which is our original Y, and then the predicted value of Y. So now to know the number of data points that you have in your data set, so you can use length function. I'm sure we all are used to this function, length. Great one. So I'm sure we all are used to length function to see the number of data points in our data set. So the first thing that we now want to calculate, so this is just like because we are bosses and then we've been taught Python, given this formula, we all should be able to like implement it ourselves. So we are just trying to implement it ourselves here because we are Python bosses. But then we can also easily use sklearn scikit-learn metrics. All you just have to do is from sklearn, import metrics, and then we have this like oh god. We are bosses, oh. In fact, one of our assignments, because of our time, let me see, without using sklearn, so that's assignment 1. Let me see how you implement root mean square error yourself. So I don't want to, because of our time, I have to move fast. So let me see how you implement root mean square error yourself without using sklearn. But with the help of sklearn, right, you can just do this. The y-hat is not defined. No, you are Python bosses, please. Because for you to move on to machine learning, you are Python bosses. Yes, Abib, you are having a name error, which is telling you that the y-hat is not defined. Probably because when you were predicting, when you wanted to create a new column in your data frame that we created above, you didn't name it y-hat. Maybe you named it something else. So go to your notebook and check what you named this new column that will contain our predictions from the model. What did you name it as? Check. Exactly, I like that. Claim it with faith, your bosses. Okay, so Abib, you have to create a new column in your data frame to that you want to put in the values from your model prediction. You know that when we were predicting, we saved those values to a variable name, which I named ypred at my end. So now we want to create a new column for this in our data frame. And I'm sure we all know how to do this. Your name of your data frame, then in square parentheses, the name of your column, and then equal to the variable that contains the initial prediction. So I'm sure you'll be able to do that. So yes, you can just use sklearn for now. So for our assignments, I want us, you show us how you did it by yourself because you're a Python boss. So sklearn has helped us with the implementation of that though. But now we had a problem initially. We saw that the relationship between the features and our targets, we saw that, oh, they were not actually linear. Okay, so we saw that the relationship between the features and our targets, they were not linear. So I'm sure we almost be done now with the metrics part. Okay, so I know we are all done. Great one. Moving on, initially, when we plotted our features against the predicted targets, in which if you scroll up in the chart, you'll see the code for visualizing that. You can just copy, paste it at your end so that we can move at a faster pace. So now, when we visualized that, we saw that, oh, the line was not meeting with all the points, which is telling us that, okay, you are doing something wrong, then Abimbola, you should be able to do that. Look at my end, highlight. Highlight. We're on Control C. I think that should work. Of course, definitely to work. So definitely you're doing something wrong. Moving on. So we saw from that visual, let me show us again. Maybe you didn't highlight. That might be one of the issues. Highlight and then control. Oh, okay. So you can just visualize it later, because allowing you to like type it will take a lot of time. All right then. So we can see that we had this, which shows that a linear relationship does not best fit our data. So in this kind of situation, what do you do such that a linear relationship is not the best fit for your data? So in this kind of situation, you can try using a polynomial regression. So we can try to use a polynomial regression. So what a polynomial regression does is that it helps to transform the inputs to a polynomial state, right? Such that you can use it for a data that does not have a linear relationship. That's a data that has a non-linear relationship. So it will first transform the inputs, which is your independent variables, which is also your x. So it first transform it to a polynomial state. Then you can now use it in your linear regression. Then you will see that, okay, you should have a better fitting for your data points when you visualize this. So from scikit-learn also, you just have to import your polynomial features. Someone might have a question that, oh, why are we using degree equal to 4 here? Well, based on the data you have, you can use a try and error method to check the best degree that will best suit your data. Instead of doing your trial and error one after the other, you can also like put the different degrees in a list and then try which one will best capture the relationship, right, in your data. So you can see that I've been able to do this. Okay, all right, noted. And the assignment, so okay. So we can see that the importing polynomial features would help us transform the input, which can also be called our x, which can also be called our independent variables. It would help transform it to a polynomial state such that it would capture the non-linearity in our data set. So now, just like we did before, would using our linear regression model, we'll fit. Now, instead of just using X, we use our transformed features. You know, when you're using fit, you're training the models, right? Giving these features, these are the targets, giving these features, These are the targets. All right, so instead of using our normal x, you are going to use the transformed x from your polynomial feature class. So once you run this, so the score, I'm sure we all know what the score does now. So you can see that we have a higher value, which shows us that, yes, we've been able to indeed capture the relationship between x and y, because we can see that we now have a higher value for our coefficient of determination. And we know the higher the value of our coefficient of determination to 1, so the closer the value of our coefficient of determination to 1, the better our model. So initially we had 0.89 something, but now we are now having 0.99 something. Great one, Rashid. I'll explain that before the end of the class, because we still have to cover classification today. Okay, so now that we use our features that have been transformed using polynomials, so now we want to predict. But you won't just predict based on your features that way. You have to transform the features also to a polynomial state, so that you take your model here and then you fit transform it, just like you did on the one you want to use to train your data. You also use it on the one that you want to use to test on the features that we also use it on the features that we want to use to test the model. So now that's why we are first transforming these features before passing it into predict. So after predicting our values, the model will generate a new equation, for the intercept and our coefficients, because it is now using a new equation to calculate values for our targets based on the features. So you can see that this is a better representation. Right, of our data. So this is a better representation of the kind of relationship between our features and our targets. All right, so we've been able to see when to know that. We now know that, okay, when we see a machine learning task that wants to predict continuous values, we can identify it as a regression task. We've concentrated on only one model today, which is a linear regression model. We've seen how to use a linear regression model to predict continuous values, and we've also seen how to evaluate our model by using some evaluation metrics like root mean square error, mean absolute error, R2, coefficient of determination, and of course mean squared error. So we know that these evaluation metrics, they are specific to regression tasks. As we move on, we'll see evaluation metrics that we can use for other type of tasks in supervised machine learning. Can't we just use the variable we use for the transform? So here, because we just created a simple data set to use to work. Normally, we should have a large data set with plenty rows. So once we have this, which is what we are going to see as we are moving on, as we want to now do classification. We are going to see how to split when we have a very large data set. We have to first split the data set into train and test. So when we split it into train and test, we use the train part to train our data set. And then in that kind of scenario now, let's say you have your train data set as X, you want to fit transform, of course, on the train data set. Then for your test, you will just want to use transform. So you do not use the same value. Don't use the same value. I think that is Rashid. Don't use the same values because this is a small data set that we just generated. That's why you think that, okay, since X is the same thing now, why can't we just use the same thing? No, don't use the same thing because normally you would not have the same thing in your training and in your testing data set. They are going to be different. So you have to know how to do this differently. Oh, Kingsley, I thought you were following before because I can see that you pasted some things that we had, some errors that you were having. So where did you get lost from? So Favor is saying we use dot fit and now we are using dot fit transform. Why didn't we use only dot fit again? Okay, so when we use dot fit initially, that is with our linear regression model. We are just training the data set. So when you're using only dot fit, right, you're just training the data set. But now we said that we want to transform the values in our independent variable, which is our X, want to transform it polynomially, right? So that is why you are using fit transform. And if you look at the code, you can see that it is the one for the polynomial, like to convert the features to a polynomial state. That is the one we are using fit transform for. But to ordinarily train the model, to just only train the model, you can see that we are still using only fit. So I think you'll be giving response to that in your group chat. So if you have any questions about what we've done today, you can ask in the chat before I move on to classification. So we've seen an example for regression. We are still going to move on to classification before our time elapses. So I think it was Rashid that asked the question about overfitting and underfitting. So overfitting is when your model crams instead of learning, right? It's crams, like giving these data points, it crams everything. And such that, just like what we are doing here, because we are training it with the same set of data points, and we are also testing it with the same set of data points. So that is why you can see that it is giving you a very I am great value, such that when you now give your model some data points that it has never seen before, then you begin to see that your model behaves, now gives you very low performance. So in that scenario, your model did not learn at all, right? It's just crammed everything that you trained it with. So, and there are different ways to prevent overfitting, which we will see as we move on in this class. And then for underfitting, which means your model did not even learn at all. Yes, which is why when you give it just in layman terms, right, Victor? I'm just trying to explain in layman terms, which is why when you give it data points that it has never seen before, then it begins to give you it begins to give you very poor results. Yes, regression, you're predicting numeric values. Yes. How do we know the particular regressor model to use? Regressors there is. Well, depending on the kind of data you have, you can try out different models and then you check the you evaluate them, right? So the normal thing to do is, given a data set, you try out different models, then you see the model that is what's capturing the effective relationship, capturing the relationship between your features and your target. All right, so moving on to classification, though we are a little bit late. We are supposed to have moved on to classification like an hour ago. Great one. So I'm sure we can all see my screen now. You can give that, you can give yourself an assignment on that, Jeremiah. Giggling is also a skill. You can always check. We have a lot of them. We have CatBoost Regress. So we have some models. We have the regression capabilities, and they also have their classification capabilities. Wow, so can you hear me better now? So we can have a CatBoost regressor, we can have a CatBoost classifier, we can have a random forest classifier, we can have a random forest regressor. So for how many, you can check that out yourself. That's for Jeremiah. So moving on to classification, we've seen that when we want to predict continuous values, like when our target, or in layman term, our answer, what we want to get right, is a continuous numeric value. We know that we are talking about regression. But when we want to predict discrete values, we know that, oh, that is classification. So we know that under supervised machine learning, we can either have what? Regression or classification. Under classification, in which what we want to predict is what? Discrete, we can have binary classification, we can have multi-class classification, we can also have multi-label classification. Okay, so when we say binary classification, just like when we were doing the introductory class, you can remember a Boolean has just two values, which is what? True or false. For binary here also, we can only have two values. It is either true or it is either, what you want to predict is either true or it is either false. For example, if you want to predict if a customer will churn or not, so that is a type of binary classification task. If you want to predict if an email is spam or not spam, that is also a binary classification task. For a multi-class, let's say you want to predict if a fruit is mango or apple or banana, right? So that is a kind of multi-class classification. Also, if you want to also predict, let's say, if an animal is a lion, if it is a monkey, or if it is a goat, right? So that is also a kind of multi-class classification. So when you're now saying multi-label classification, so a multi-label classification, that kind of task can take in 2 labels at once. Let's say you want to predict the genre of a movie. So a movie can be both tragedy and comedy, right? We can have a tragic comedy movie. So in that kind of scenario, you would have a multi-label classification task. So I'm sure we all understand the difference between a binary classification task, multi-class classification task, and then a multi-label classification task. All right, great one. So just like we can identify if a regression task is a regression, if a machine learning task rather is a regression task, we can now also identify if a classification task is either binary, multi-class, or multi-label. So as usual, we'll import some libraries, pandas, matplotlib. You can start this in a new notebook. You don't want to join everything together. So you can start this in a new notebook, import pandas, import matplotlib, import Seaborn, and import NumPy. I'm sure you must have been told that Seaborn was built upon matplotlib and you use it for visualization. And I'm sure from your previous classes, you now know how to read a CSV file into your Jupyter notebook. So in the chat, I'm sure the link to the data sets to be used for this class has also been sent. So download the data to your PC. If you are using Colab, upload it to your drive, and then you can read in the data, and you use .ed to see the first 5 rows of a data frame. Okay, so what does the last line of the import section mean? That is the percentage. Okay, so what this just does is just it's a magic command, right? It's just specific to Jupyter notebook, saying that the plot should be shown in the notebook, right? You can also work with this without putting it, right? It's not yeah, so it's just to show that, oh, the plot should be shown in the notebook itself, should be displayed in the notebook instead of, but it should also work without specifying it. So we also know that we use .head to show the first 5 rows of a data set, of a data frame rather, because when you speed it or read CSV, you now have a data frame. Okay. So I'm sure we all must have been able to do that now. We can see the first 5 rows. Wow. Abimbola is saying link to the data set. I think I saw it at the beginning of this class. I'm trying to check. Yes, so this is it. As exactly 10:46 a.m. it was posted. So we have it here. So it has been sent. So you have that already. Oh, Hero Cruise. We just started classification. We are done with regression. And since you just started classification, I don't expect you to be lost because the only thing we've done here is to explain what's binary classification, multi-class, and multi-label. It's just to explain what they are and then we differentiated between them. That's all we've done here in classification. So just like I said before, it's just a magic command that says that, oh, the plots generated, right, should be displayed in the notebook itself. So immediately you run the code for your visualization, you see the visual directly. So for delimiter, what is just delimiter means, you know, CSV files means comma separated value file. So you're just telling PD.read CSV that, okay, even though this is a CSV file, the delimiter there is what? A comma, right? Sometimes the delimiter for your file might not be a comma. Sometimes it might be a full stop. So you have to specify. Sometimes, right, not at all times. Sometimes you might have to specify the delimiter in which you want to split your columns on. Sometimes it might, delimiter just be the separator, right? So sometimes it might be comma, sometimes it can be full stop. It can be based on what you have in your data set. So I'm sure we all have been able to view the first few rows of our data using .ed. So moving on, we want to use value count. So what value count does, we are using value count on the gender column. And we can see that the gender column contains what? Categorical values. In simple terms, it contains strings. Our age columns contains what? Integers. In simple terms, it contains what? Whole numbers. Our estimated salary also contains integers, which in simple terms, sorry. All right, so our estimated salary also contains integers, right? Which in simple terms will be whole numbers. And then we have purchased, right? Which we can see the values there. So we are doing value count. What value count does is that it looks at what you have in that colon gender and to tell you that, okay, in this colon gender, we just have two values there, right? Male and female. The number of females in the colon gender is what? 204, and the number of males in colon gender is what? 196. So as I did value count for colon gender here, at your end, I want you to do value count for purchased. So what are the unique values that we have in this purchase column, and how many of them do we have in the purchase column? Okay, so great response, Lawal. 257 and 143. So let's see if that is correct. So all you just have to do is, instead of using gender, you use what? Purchase. So then you can see that in the purchase column, we have what? 0 and 1. And for 0, we have what? 257 values. And then for 1, we have 143 values. So 1 is true and 0 means false, right? So in this classification task, want to predict so want to predict the value of purchased. So let's see. Wow, it's almost 12. I'll have to take a little out of your time because we'd have to complete this. You already know the next question that I wanted to ask, right? So great one. So I can see that everybody's already saying, oh, it is binary classification. All right, so that was actually the next question I wanted to ask. That since we can see that purchase has only 0 and 1, what type of classification is it? But great to see that we're already responding before I even asked the question. All right, so purchase is based on what we want to predict, right? Which is the purchased colon, right? So we can see that we are dealing with a binary classification tax. So now I'm sure we all know that our model would not want to use our categorical variables in our model like that. So we have to first preprocess our data and convert the categorical variables to what? To numeric. Wow, it's 12 already. So I just have to run through this. Yeah, so we have to first convert the categorical variable. We have to first convert it into what? Numeric. So now we are using label encoder to do the transformation. Can you see here, just because we are trying to convert our categorical values, which in simple terms, strings, right, into numeric values, you can see that we're also using fit transform. So because we are trying to transform the values in that specific, sorry. Oh. Sorry. All right, sorry about that. Let me share my screen. All right, moving on. So because we want to transform, our agenda column contains categorical variables, right? So we need to transform them to numeric values so that we can use it in our machine learning model. So to do this, that is why we are employing label encoder. So we'll just use our label encoder to transform our agenda column. So apart from label encoding, we also have some other encoding techniques like one-hot encoding. And then in fact, without using label encoding, you can even replace the values with whatever numeric value you want to give. So these are the different ways that you can transform your categorical column. So now, if you now do value count on the column gender, you can see that the values have now changed to 0 and 1. So for exploratory analysis, so you want to get more information about your data. So before moving on to this, if I want to check the shape of this data, how do I do that? Okay, instead, check the shape of the data set at your end and let me know the value you get in the chart. So check the shape. All right, so we can see that we have 400 rows and 5 columns. So we can see that we have boxes, 400 rows, and then we have 5 columns. We use .info also to get more information about our data set. You can see the number of values in each of the columns and then you can see their contain nulls or not, and you can also see the data types. So that is what you use .info for. Then we want to see employees that actually purchased a particular item and employees that did not purchase a particular item. So that is why we are grouping by gender. Sorry, that's why we are grouping by purchase. So we are grouping our data to see, oh, which employees okay. So just like we've seen how to use our .info to get more information about our data set, if we want to see some statistical analysis about our data set, we can also use .describe, right? So describe will show you the total count, the mean, and then the standard deviation, the minimum value, the 25th percentile, and also you can use .describe for that. If you also want to check if your data has, even though you've seen that in .info, if you want to check if your data has missing values, you can also use isNull.sum to check for that, and we can see that in our case, our data is very clean. So that's why we are getting zeros, right, for missing values under all the columns. Okay, we can always do the visualization aspect ourselves because we are bosses. So instead of just using the features that we have only directly in our model, we want to try and engineer features. And when you are performing competing in hackathons, feature engineering really helps. When you engineer new features, you understand the problem and then you are engineering new features from your features that was given to you from the data set. You engineer features, it can even help your model attain better accuracy. So I'm sure we know about this. If else, we are bosses in this because we did this in our introductory class. So we are binning the age categories such that if the age is between 0 and 25, if the age is between 25 and 40, if the age is between 0 and 25, iGen, else we are giving them millennials. If it is between 24 and 40, okay, so if it is between 0 and 25, iGen, else. If it is between 25 and 40, millennials, else. If it is between 35 and 56. So in that order. So after binning, we'll be able to see, you can see that we are creating a new column in our data set and we are giving it age categories. If you do not want to do your own like this, as bosses as we are, oh, Hero Cruise, we changed the original column then. You can see that the gender column was changed then. So I'm sure your question has been answered. So if the age is between 0 to 25, giving them iGen. Else, if it is between 24 to 39, then we are giving them millennials. Else, if it is between 40 to 54, Generation X, and baby boomers is 55 to 73. Else, if it is not conforming to any of these bins that we've created, we are saying it should be none. So after creating this category, you would see that immediately it shows in your data set. So we are just engineering two features, which is the age category and then also the income category. So taking our estimated salary income, we are using this quarter cut function. We want to cut it into three. So the first one will take like 1/3 of our data point. The second one will take from 1/3 to 2/3, and the last one will take 2/3 to the maximum point. So that's why you can see that we are bringing it to low, medium, and high. So you can see that we've been able to engineer new features, two new features to our data set, and they are the age category and income category. So that's what I want you to see. We engineered two features, age category and income category, which I'm very sure that when you try this on your own, you would be able to do that. You can just add it as a comment to your notebook because I'm sure you won't be able to replicate it immediately. We are adding two features, age and income categories. So here we are just trying to visualize, gain more understanding about our data. So let's just move on to building our model. And I'm just going to help us in building just one right out of the model. We can always try out using the same scenario or using the same steps, right? You can try out other classification models yourself. Sorry, I know I'm fast, right? But I'm sure you are still understanding what is going on, even if you're not able to replicate it at your end. So just like during regression, we split it into features and targets. Now also, all right, so now we are also splitting into features and targets. Even for this, we don't want to make use of our engineered features yet. So we want to see what the accuracy of the model will be without using the engineered features. So I would only do this. You can add the engineered features at your end and then compare the accuracy of your model without the engineered features and with the engineered features. So we are just picking three columns as our features: gender, age, and estimated salary. Then our target is the purchase column, which is why we know this tax is a classification tax. So just like I explained before, now we have a data set with a lot of points. So we are now splitting it into train tests. We are splitting our features into train tests. Okay, so we are splitting our features into train tests, and we're also splitting the targets, right, into train tests, which is what you can see here. So we have some for train, some features for train. Given these features, these are the targets for the train. So then you also have some features that we use to test the model, and then we also kept the targets for those tests. Yes, we are using just the original features. Okay, so since we've already preprocessed, we've done everything, we've splitted, so we just have to fit in our features and our targets, which I'm sure we all understand, just like we did in regression. Then we are using .fit to train our model, and we are using predict on our test data set, right? You can see that we are not putting our target here. So we are using predict only on the test data set, then giving the model predicts based on these features, right? Predict values for us from what you understand. Then for metrics, for classification metrics, you can see that we are not using root mean square error here or mean absolute error or mean squared error. You can see that here we are using accuracy, precision, and recall. I can also see the ROC-AUC curve and the confusion matrix. So I'm sure in your next class, all this will be properly explained, all these metrics, but you've been able to see the difference between, definitely the categorical variables were converted using label encoder, Jeremiah. Yes, so in your next class, today is Thursday, and you'll be able to understand properly each of these metrics. You can also check it out online, read about accuracy, read about precision, read about recall, read about confusion matrix. You can see that all these are specific to the classification task of machine learning, and you can see for the root mean square error, mean absolute error, and yes, I stopped sharing already, and they are all for the regression task. So I hope in your next class you'll be able to gain more understanding about this. Yeah, right. You'll be able to gain more understanding about these metrics and how they work. So that'll be all for today's class. We've done a lot. We've done a lot in today's class. We've been taught about regression, we how to build a regression model and how to evaluate one. Also moved on to classification, how to identify a classification task, how to preprocess when we have a categorical colon, and we also saw how to create a model and also how to evaluate this model using recall, precision, confusion matrix. And we also saw that, the evaluation matrix for classification, they are different from regression, just as the models are also different. So tomorrow's class, I hope you gain more understanding to these concepts. Thank you very much for joining, and that will be all for today.